y equals 2x minus 5 over 4x times x plus 1 underneath. In form, we know it's a partial fraction, a proper partial fraction, so we could write a over 4x plus b over x plus 1. And by doing that, we can see how it shoots off to infinity here, because it's going to shoot off when x is 0, so that'll be an asymptote here, because it's underneath. And in this part of the partial fraction, we can see it shoots off to infinity at minus 1. So let's draw in the asymptote here, because we need to look either side of it to see how it shoots off to infinity. And we'll also need to look at either side of 0 as well, of course. Now as x tends to infinity, if you look at this, both of these will tend to very small fractions. So looking back at this then, x tends to large, there's an x squared underneath. This will be positive, this denominator will be positive, but it will be much, much larger. So we tend to 0, don't we, on the positive side. When x gets large negative, if we look at this again, this will be negative, and the underneath, because the x squared, will have a negative times a negative, which is a positive. Negative over positive is negative, a very small negative number then, when x gets large negative down there. So we got a feeling it's going to go down like that, that's what we want, I think, and it's going to shoot up there like we want, isn't it? That's what we think might happen. So we'll need to look either side of 0, and either side of minus 1. So let's look to the left of minus 1 on this side here, and we'll put the signs in a combination just below here for reference sake. So on the negative side of minus 1, the top part of the number is negative. The bottom two parts of the number, this will be negative. And this number here, because it's slightly less than minus 1, this will also be negative. 3 negatives make a negative. So we'll shoot down to infinity on the negative, won't we? So what we thought was going to happen seems likely to be what happens. Now, just bigger than minus 1, look at this again. This will be negative, clearly. This part here will be negative. But bigger than minus 1, this number here will be positive. So 2 minuses make a positive, so we're actually going to shoot up to infinity here. So I'll put a couple of X marks here now to denote that. So on this side we've just worked that out, that it shoots up to positive infinity here. The left hand side of 0 now. On this side, small negative numbers, this will still be negative. This will be negative. And this will be positive, won't it? So again it's going to shoot up to plus infinity. Up there. On that side of 0. And then on the plus side of 0, small positive numbers then, this will still be negative. This constituent will be positive, and this constituent will be positive. So we'll have a negative down here, won't we? So let's mark that in now, we know. So it's going to shoot down to infinity down here. So it looks like what happens is it comes up from here, up from here, and then turns and goes along that asymptote. If I can try and draw it a bit better than that, would be good. And then it's going to come up from here. It's going to have to go through 0. It's going to have to turn and then turn back on itself and tend to 0. And this one's after, we don't know how low it's going to go, whether it overlaps here or whether there's a gap. And we'll say a bit more about that in just a moment. So we'll just do it illustratively here, and it shoots back up there. Now this could be any height here, couldn't it? We don't know if there's a gap here or not, but characteristically speaking, this is what the curve looks like. If we wanted to determine these values here and here, the max and min, we could do differentiation and let it equal 0 and find the turning points. Or what we could do actually is just move this. I'll just do it first and then explain as I go. This is 4x squared plus 4x, isn't it? Move that to be up with the y. So here, 4x squared plus 4x is what we've got underneath. We're moving that up to be with the y, is equal to 2x minus 5. Now let's rewrite that as a quadratic in x. So we'll have 4yx squared, won't we? Now how many x's have we got? We'll have 4y from this bracket, x's, and we'll bring over a minus 2 lots of x as well. And then the only constant we've got is plus 5. So we want values for x being real to plot points on this curve. So the x's have solutions then to this quadratic, provided that the discriminant b squared minus 4ac is greater than or equal to 0. So b squared minus 4ac must be greater than or equal to 0. So that tells us then, so what do we get from that? B squared is 4y minus 2 squared is greater than or equal to 4 times a, which is 4y, times c, which is 5. So we get an inequality in y, which we can let equal 0 to find out the actual boundary values. And that will then tell us what values of y we can't have, and we can have. So that can tell us the heights. It leads on from solving this quadratic, finding the roots, and they will correspond to these uppermost and lowermost values, if there are values to be found. But I'm not going to do that here, because characteristically speaking, we've worked out the shape of the curve. So let's just try and go into our widget now, and we'll type that in and see what we get. I'll do it as quick as I can. So the number on top is 2x minus 1, so put that in a bracket, divided by a big bracket 4x, open bracket times x plus 1, close the x plus 1 bracket, close the bracket underneath. From minus 6 to 6, let's see if that gives us any. So we can see we've got something here. We've got the left and right parts okay, but the graph isn't seeming to plot the middle section, is it, from minus 1. So let's do from minus 2 then, see if it encompasses it that way, up to 1, to see if we can get the middle section produced from the plot as well. There we go. So that's quite nice, isn't it? So there is a gap, and you can see a minimum there. So it looks like we're okay with that plot.